I'm going to show you kind of some basics of graphing functions. This is really the most basic form and not really the ideal way to graph functions. But if you have something like a quadratic and you don't know what that graph looks like or how to do the transformations, this is how you would graph something like that. This is something that could work for pretty much any function, but there's definitely some functions that you should know the general idea of what they look like. So I will go over what those functions are and what those look like, but we'll just start out with an example of what I would do if I were going to graph this. So you would definitely want to make a table to start out with. And then over here, notice that I put f of x. F of x is just the exact same thing as y. So you could put x and y there. I put f of x because our function says f of x equals instead of y equals. So the general numbers that I try to choose when I'm graphing functions is -2, -1, 0, 1, and 2. And the reason I choose those is because I kind of get an idea of what this function looks like to the left and to the right of that y-axis. Now, if you had something that was translated in one direction or the other a lot, you would probably want to choose some other values in the direction that you don't know what it looks like over there. So if I didn't know what it looked like on that far right side, I didn't know where to draw that arrow to, I would probably want to pick 9 or 10 or some other values so that I could get an idea of what that function looked like. But in general, these are the values I always start with. So when you're doing this, you're just going to substitute those values in just like when you evaluate. And I have another video on evaluating functions. That's the same thing. You're just doing this 5 times over again. So we're going to substitute that in there. So I'm going to write this exact function, but instead of x, I'm going to write a -2 in parentheses. So now you can type it in your calculator if you need to. You could go -2 squared minus 5, and you get -1. I'm going to erase this because I don't want it to confuse you when we go to use these values. Now, here's a trick when you use your calculator. You can just go up to what you already have and click enter, and it just puts it there again, and you can just scroll over to change this to a -1. So now when I type in -1, my answer is -4. We're going to do the same exact thing, but we're going to do it with 0. I'm going to actually have to delete my negative sign on here, but then I can put 0. Ooh. Which is -5. I can do the same thing with 1, which is -4. And I can do the same thing with 2, which is -1. So these are all just points now. This is the point -2, -1. This is the point -1, -4. This is 0, -5. This is 1, -4, and 2, -1. Just go ahead and plot those points. -2, -1. -1, -4. 0, -5. 1, -4. And 2, -1. And my graph would look something like this. The bottom part of that is terrible, but you get the gist. So this is what my graph would look like. So that brings me to my next point. I need to make sure that I kind of have a general idea what some of these functions look like. So here's the important ones. Linear functions could look like this. This would be a rising or a positive slope. It could look like this. This would be a negative slope. Or it could look like this. This would be a zero slope linear function. They're all lines. In math, there's no such thing as curvy lines. There's curves and there's lines. So linear functions are all lines. Quadratics are a U shape. So they'll either look like this or they will look like this. cubics are like this. They have an x cubed. Quadratics are x squared. This would just be x. Okay, so cubics will look like this. They kind of curve upwards. They never have the same y value though. Like it looks like it gets to where it's exactly horizontal, but it never actually is. Or they can look like this. Square roots are going to look like this usually. My arrow's not great. So they have a point here and then they'll be going up from there. So these are some that you really should know what they look like. If they ask for an absolute value, absolute values look like this, a V shape or an upside down V shape. But these are some functions that you should definitely know the general kind of look of them. And then you can go ahead and use that table method to fill out a graph and you kind of know what direction it's going because you know the general shape of that function. So go ahead and try this one. Make yourself an x and f of x table. And go ahead and try this one out. Make sure you try it because learning happens when you go ahead and struggle through a problem. If you just always look at the examples, it looks like you can duplicate it, but when you actually go to do that, you realize you can't. So make sure you actually try this, pause the video, and when you press play, you can come back and see the solution. Okay, so you probably chose the values -2, -1, sorry, not 0, 0, 1, and 2. So I'm going to go ahead and use those values so we can see what that looks like. So this is the square root of -2 plus 4. So when you type that in your calculator, you have to get that square root, and then you do -2 plus 4. So it's approximately 1.4. Okay, so then I'm going to do the same thing, but with -1. Which is approximately 1.7. Then I'm going to do the same thing with 0. Which is 2. And the same thing with 1. Which is approximately 2.2. And then I'm going to do the same thing with 2. Which is approximately 2.4. And then just go ahead and graph those points. -2, 1.4, -1, 1.7, 0, 2, 1, 2.2, 2, 2.4. So you can kind of see this. I should probably move this one down just a little bit. You can kind of see this general shape forming, which we said a square root looks like this. Okay, so this is where my knowledge of square roots can help me, okay? So usually square roots start down here on the x-axis unless it's been translated. So I kind of want to figure out where that's going to hit 0. So I know that -4 plus 4 is 0.